low heat cement. As we know, tricalcium silicate and dicalcium silicate are main component of cement which form the CSH gel and the calcium hydroxide in the presence of water. But apart from this, a lot of heat is generated. And in mass concreting, this heat is so excessive that it can generate cracks, resulting in the structure failure. Now, more the volume of concreting, more will be this heat of hydration. And more will be the heat of hydration means more cracks will be generated in the concrete. So, how to stop these cracks in mass concreting? To stop these cracks, we need to reduce the heat of hydration. And to reduce the heat of hydration, the rate of reaction must reduce. And in order to reduce the rate of reaction, we need to reduce the content of tricalcium silicate and tricalcium aluminate, which react immediately with the water to form heat of hydration, and by increasing the quantity of dicalcium silicate, which reacts slowly in comparison to the tricalcium silicate. And in this way, we can reduce the rate of reaction and hence reduce the heat of hydration. Let's explore more. So, in low heat Portland cement, heat of hydration is generally produce a large quantity of heat. This release a large amount of heat results in the formation of large cracks. So, we use low heat Portland cement in which the rate of heat released from the concrete is lesser than the ordinary Portland cement. To achieve the low heat cement, we reduce the quantity of tricalcium silicate and tricalcium aluminate, while increasing the quantity of dicalcium silicate. This reduction of compound retards the chemical action of hardening, thereby reducing the evolution of heat. This action makes this cement to gain the strength at a slower rate. However, the ultimate strength is nearly the same. Properties of typical low heat Portland cement is very important to understand. So, the heat of hydration released in 7 days is 272 joule per gram, whereas in 28 days is more than 300 joule per gram. The fineness of the low heat cement is 320 meter square per kg, which is more than the ordinary Portland cement. The expansion of the low heat cement should not be greater than 10 mm in Le-Chatelier test or 0.8% in autoclave test. The initial setting time, instead of 30 minutes, it's 1 hour. That makes it low heat cement, though the final setting time is 10 hours, which is similar to ordinary Portland cement. The strength gain in 3 days is much lesser due to low rate of reaction, only 10 Newton per mm square. Even in 7 days, it's only 16 Newton per mm square. But in 28 days, its strength is 35 Newton per mm square. The major use of the low heat cement is in the large mass concrete work such as dam, large raft foundation, where lot of heat generation can result.